focus of the video today, no pun intended, is the high efficiency modification I did to the Benjamin 392 multi-pump pneumatic 22 caliber air rifle. Actually, the past two videos have been about that, but today I'm going to describe on paper what I actually did. And last week we looked at chronograph testing, and the velocities were all over the place. You know, I mean, I got over 700 feet per second at 8 pumps, and then over 700 feet per second at only 3 pumps, and if I remember right, over 600 at 0 pumps. So what was happening, of course, is that I inadvertently turned it into what some people call an air conserving pumper, but that's actually more a state of tune than it is an actual modification, and I'll describe why that happened. Okay, and I'll also tell you why that's a good thing, and you just have to use a different technique shooting it. Okay, so here's what I did with the valve. I'm going to draw a depiction of the valve. Best I can, anyway. Okay, this is the outside surface of the valve, and probably not too much reason to draw the thickness of it, but what happens is, okay, there's a parting line here, so it breaks into two halves. I guess you can see what I'm drawing there. So this is the valve, this is the forward part, and the piston, which the pump handle moves back and forth, is here, okay, and the hammer strikes the shaft that comes out here. Okay, this is a parting line where it screws together. And when I was showing you the modification, showing the actual valve, I unscrewed that, and one of the problems is headspace between the piston and the check valve. The check valve is just a little plug right here that stops that hole, and I'll go ahead and draw best I can what's going on. So there's a coil spring, and it goes actually all the way. It does two jobs in the factory valve, and so there's a cavity here, there's a little wall here, and there's a poppet valve. Right here is the poppet valve. Describe this the best I can. Here's the hammer, which is spring loaded. Okay, and the sear, when you pull the trigger, the sear releases the hammer to hit the poppet valve. Okay, so when you pump the handle, it compresses air, it picks up air on the open stroke. On that stroke, see, it picks up air from right here. And then when you close it, it approaches the valve, and it actually should come in contact. It should just contact the front of the valve, which what that does, it compresses air, and it pushes that check valve, pushes that plug open. The air pressure pushes the plug open against the spring pressure, and it fills this area with high pressure air. And you want the headspace between the piston and the front of the valve to be as little as possible. But because of manufacturing tolerances, it's not going to be as tight as it could be. Now, they used to make it with where the pump rod was adjustable so that you could tighten that up, but they don't anymore. So one of the things I did was there's an O-ring in this where the two halves of the valve screw together, and I unscrewed it, put an additional O-ring in there and screwed it back down to move because it's fastened to the wall at the back of the valve, back half of the valve. So by unscrewing it just a little bit and putting an additional O-ring in there to take up the space, it actually moves the front of the valve towards the piston a little bit. And I went too far with that, and I ended up having to go in and screw it back in a little bit because I couldn't close it all the way. So, but I basically used that extra O-ring to account for there not being an adjustable piston. I used that as the adjustment instead. So that's one of the things that increases the efficiency of it, is reducing this headspace. Okay. Another problem is that this check valve, this stopper here, doesn't need much spring pressure, but the poppet valve does need quite a bit of spring pressure, and it actually is a balance between the hammer spring and the poppet spring, because what happens is there's compressed air in here, and there's a port here on top of the valve. So what happens is when this poppet valve opens, the high pressure air in here escapes into this chamber and out the port, and thus propels the pellet. So as a cost-saving measure, the older Benjamins and Sheridans had a separate spring, and there was a lightweight spring that worked on the check valve, and it sat on its seat, and then there was a heavier spring for the poppet. But when Crossman took over and redesigned it, which they actually, they made it easier to work on, and they did make some improvements to the design. But one thing that's not so great is that to simplify construction, they replaced the original setup with just a single spring that works on both the poppet valve and the check valve. And that's not so good because it's way too much pressure for the check valve in order to be enough for the poppet valve. Poppet valve requires quite a bit of pressure, and that's why you hear so many complaints about the Benjamins being difficult to pump, because there's too much spring pressure there. And it also reduces performance because you're throwing away about, from what I've heard, 200 psi in additional pressure that you don't really need there. So what I did there was I got a washer that was just the right size, and I used a brass washer since the valve is brass. Steel would work, but I prefer to use brass. That way you don't have that dissimilar metals thing. So I put a washer in there so that this spring could seat on the washer, and I could put a separate lightweight spring to seat on the other side. And there's just enough of a lip in here for that washer, that number 10 washer, to seat on. And because this spring is heavier than this one, then it doesn't try to move this way, and it's got a lip to prevent it from moving this way. So that worked out well. Now the reason that that turned it into an air conserving pumper is I did not shorten this spring, even though it's seating, you know, 3/8 of an inch or some, maybe a 1/2 inch or something further in this direction, further towards the rear than what it was from the factory. So therefore it's pre-compressed. So that places it, that makes it quite a bit stronger than the hammer spring. So what that does is, with the factory set up, you can pump it up to, like this one. Well, with the factory setup, you can pump it to the maximum recommended pumps and it'll dump the entire charge with each shot. And that gives you maximum performance. With this one, it would actually, although the maximum recommended is 8 pumps, it would actually go all the way to 12 pumps and still fully dump it. And performance increased all the way up to 12 pumps. Now, if you've ever heard of Mach 1 air guns, Tim McNeil, I think his last name is, he's the #1 guy for Benjamin and Sheridan pumpers. And the modifications he does increases the performance, but it's still a fairly linear performance increase per pump, from 2 pumps all the way up to 14 pumps. And that's one of the things he does. He strengthens some of the components, some of the pump components especially, to make it handle up to 14 pumps. And he makes it so it will dump the full charge even at 14 pumps for maximum performance. Now, with an air conserving setup, you no longer have that. You basically have the original performance level, which is, I actually gained a little more performance than factory, because it'll do 725 feet per second or something like that with 14.3 grain pellets, which it was only doing about 640 before the modification. And that's just because of the efficiency improvements. But you no longer gain anything by going over 7 or 8 pumps. And you really, well, you know, you could probably pump it 3 times and get approximately the performance that you got at maybe 4 pumps before the modification. But one thing you can't do, as we saw from the last video, is you can't pump it 8 times, shoot it, and then pump it 8 times and shoot it like you could before, because it's not dumping the full charge at 8 pumps. So what you have to do is, the advantage there is that you don't have to pump it 8 times all the time to get maximum performance. What you can do with an air conserving pumper is pump it all the way up to 8 times for the first shot, and then for the successive shots you have to have a way to determine what the pressure remaining is, or when you reach the set pressure again. And I'll show you how to do that in just a minute. But what happens is you can sit here and shoot shot after shot at full power, at the full, 700-ish feet per second, without having to pump it, but maybe 3 or 4 pumps. Varies from shot to shot. And I'll show you how that works. Before we start shooting, there's one mod that I left out that I'm going to describe real quick. There's an O-ring here in the body of the valve, and that's to seal it. No, actually it's on, well, I'm not sure. I don't remember. I think it's on this side. Anyway, there's an O-ring on one side of the port, but not on the other side. And I put it in my mini lathe and cut a groove for a second O-ring, so it has an O-ring on each side of the port. That's to prevent air from escaping, so you have more air to use. I don't know how much that helps or if it helps at all, but it wasn't difficult to do, and it certainly doesn't hurt anything. So that's enough of that. Time for some shooting. I've got my pellet trap over there to catch it, so I'm going to go ahead and fire the shot that's in it. I'm not sure it has one in it. We'll make sure it's empty anyway. Okay, you can hear the difference there. Alright, that's dead empty. So, I always like to cock it before I pump it, because that takes the hammer pressure off the poppet, so that it seals better. So we'll pump it 8 strokes. Okay, so after you close it, after the 8th stroke, here's what you have to do. Unlike the unmodified tune, you have to keep track of how much pressure is in there. So you got to get a baseline. And the way you get that baseline is after you close it all the way on the last stroke, you just pop it open and look at the piston. You can see where it comes to. Now what I do is, alright, that's about a finger's width. About the width of my forefinger. So what I'm measuring is this is not actually the piston, this is the op rod where the lever attaches to the op rod. So the bottom of that to the bottom of the slot is the width of one finger, and it's going to because what is in the tube right now when it's closed is, or what's in the tube is the volume from the pressure that's left over from the check valve. So that gives you an indication of how much pressure is actually in the valve. So you don't open it all the way up to where it can draw air in again. You just let it open up under its own power. So put a pellet in and shoot it. Okay, once again, cock it and pump it. Three strokes. It's not enough. Five strokes. 6 strokes. Okay. Alright, 6 strokes puts it at where it was before at 8. I always go at these 3. Well, look at that. 4 strokes. And, you know, after you measure it, just close it. Don't open it all the way and close it again. because that'll draw more air in. Four strokes. It's just about there on 3 strokes this time. So we'll try it one more time after this shot. Still needs 4. But you see what it's doing there. 8 strokes on the original shot, and then approximately 4 strokes on each succeeding shot. And that's what that does for you. And those 4 strokes are giving me the same power as 8 strokes normally would. So it basically just makes it quicker to pump.